So each regular expression is a notation for a language, and specifically for a regular language, right? So it's very, very important. And a language is a set of words. We keep saying it again and again. And if A is a regular expression, we write that L of A is a language described or denoted by that regular expression A. So L of A means the language of the regular expression A. So this sort of notation you will find quite a lot this week. So this is the definition of a regular expression, and we're going to define it inductively. So we're going to begin that any character or any letter from the alphabet alone is a regular expression, right? So if A belongs to the alphabet, if A is a member of the alphabet, which is a set of characters, so if A belongs to that set, this A, individual letter A, is a regular expression. And empty string is a regular expression as well, right? So empty string is a regular expression, and every individual letter from the alphabet, and again, alphabet is that character set from which we define languages. So A and E are regular expressions. Suppose we have two regular expressions, R and S, and you can call it anything you want, but the point is there are two regular expressions. What those are, forget about them. Just focus on that there are two regular expressions, R and S. And if we put a bar, which is OR symbol, that means either R or S. So if R is a regular expression and S is a regular expression, we can have the union of these two. And again, of course, you know the union. A union is sort of either you belong to A or you belong to B. You belong to A or B, right? Similarly, if we have two regular expressions R and S, we can concatenate them together. Quite simple. And R star is, you used to call it Kleene star. Kleene is the name of that computer scientist who came up with this idea. And it means that 0 or more strings from this regular expression R. So it is the representation as it includes the empty string, then 1R, 2R, 3R, 4R, and so on and so forth. R can be any regular expression. For example, A plus B or ABB, whatever that is. So these are the operations you can perform on a regular expression. So the inductive definition is that any letter, that is key, any letter from the alphabet is a regular expression, the empty string is a regular expression, and then these three operations, the concatenation, the union, and the Kleene star. There are some regular expression extension that we are going to need for the tool we'll be using to generate the lexical analyzer. If you put a question mark after a regular expression, that means 0 or 1, not more than 1. Either it can be 0 or it can be 1. We're going to see examples which will make it very clear. But just keep in mind the question mark is sort of optional, and that means either we don't have this thing, or if we have it, it's going to be only 1. And the second is R plus. That means it's a kind of modification of the R star, which means R star is 0 or more, and R plus means 1 or more. So you must have at least 1 from the regular expression R, or you can have any number of them, right? And the grouping is if you put parentheses around the regular expression, it is equal to as R. So these are some of the extensions, right? Then we have the square brackets. If you put a square brackets and you have 3 concatenated symbols, letters, or characters, that means either A or B or C, any of the listed, but not all of them, right? So if we say A is a string based on this regular expression notation, or either B is a string or C is a string, but not AB, right? It's not. It doesn't mean that you have to pick up this whole one word. Then we can specify ranges, again square brackets, but you put a hyphen, that means any of the letter from A to Z, right? And the caret symbol, which is if you hold down the shift key on the keyboard and press the 6 key, 6 digit, that means it's going to print this caret symbol. That means anything but not A and B, right? Simple. It's the negation. So these are some of the examples. So if we have a regular expression A, that means this regular expression defines a language which contains only one word, and that is going to be A. If we have a regular expression AB, which are the characters from the alphabet, that means we have only one string in this language defined by this regular expression, L of R, and that is AB string. If we have a regular expression and we have the union between them, that means the language defined by this regular expression contains either the string A or the string B, right? So this is a union between them. So it's like we have two sets. One set contains the character A, another set contains the character B. If you take a union of them, it's going to be A comma B. So A string and B string, they both belong to this language, or the language defined by this regular expression. Similarly, for example, if we have AB and we put a star around it, that whole star, that means we can have either empty string, the language defined by this regular expression, or described or denoted by this regular expression, L of R, is going to be either empty string or AB or any number of AB concatenated with one another. In exactly the same order. You cannot have BA in this language because AB is part of that regular expression. That means it's a pattern that we can have AB, then again AB, 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 but you cannot have BA, right? I know that it's simple, but this is just an important point. Some students get confused, so I wanted to remind. And we have then a letter A in the regular expression, and then the OR, and then the epsilon. This one is interesting, right? That means either A and then concatenated with B, or nothing concatenated with B. So the first string can be, if we can take only A from this OR because it's an OR, and then concatenate that with the B, we can have AB string that belongs to this language defined by this regular expression. Or if you concatenate empty string with B, again, empty string concatenated with any character is that character itself. So we can have a B string that belongs to this particular, the language defined by this regular expression. So these are some of the examples. Try to pick up another examples, take a regular expression on your own, and try to find out which words belong to the language you design with the regular expressions. Now let's talk about the tokens in the language. So an integer is some kind of token, and every programming language allows programmer to specify integers in the source code, so they represent one token class. You can call it integer or number or whatever, that depends on the design of the language. But the name doesn't matter. What it matters is what is an integer in a programming language. It's a non-empty string of digits, right? So we can have 1, that is an integer. We can have 100, 100, that is an integer. And 100 is nothing but sequence of characters. So in regular expression, we have a digit. That is a regular expression. This is the extended notation, remember. And we can say 0 or 1 or 2 or 3 or 4 up to 9. So a digit means either one of these letters, right? So if we want to describe this token integer using the regular expression, we can then say digit star. Remember the R and R star, which means one or more, right? So if we don't have anything, if this second regular expression term doesn't produce anything, for example, then we can have at least one digit. So it's going to represent all the whole numbers. So for example, you can say, let me just open this small tool and remove this one. And so for example, let's say we have the letter, the number 30, right? So 30, according to this regular expression. So can we produce 30? Yes. Let's say 3. And then from the second one, we take 0, right? Because we can digit represent any of these numbers. Digit can be replaced with any of these numbers. Kind of derivation you are gonna see in the syntax analysis. So the first digit, I pick up 3 for that. And for the second one, I pick up only 0, right? Because digit star can produce any number of digits. So we say 3. So for example, if I remove this and I say, let me just say, let me just delete everything. Say for example, does it produce this string, 3, 9, 7, and 0? According to this regular expression, we pick up 3, right? For digit 3 can be replaced with any of these numbers, so I replace it with 3. And then for digit star, we say there are 3, so I can say I can pick 3 things because star means 0 or more. So we can say I pick 9 and then 7 and then 7. Remember that R and then RR. Remember that the representation of and then RR. We can pick any number of characters for digit star. So yes, this will represent only the whole number or the integers. An integer is basically a number that doesn't contain any decimal point.